All right, and we're back to it. Another day, another topic on rational functions. We're going to change the conversation a little bit today because now we're going to talk about rational inequalities. Now, the good news is there's really nothing new to teach you about solving rational inequalities. We're going to really take two things and put them together. What we've already talked about with finding vertical asymptotes and x-intercepts of our rational functions, and some of the concepts we've already discussed with polynomial inequalities in a previous unit. And so we're going to put those two things together, all right, and solve rational inequalities. So to get us thinking about rational inequalities, what we have is a graph here in our opener. So what I would like you to do, all right, is to do parts A and B and C here for problem 1. All right, so look at this graph and in interval notation, tell me where this function is less than or equal to 0. And then in part B here, identify your vertical asymptotes and your x-intercepts. And those we've been friendly with you here. We've given you everything in factored form. And then, all right, talk about and maybe see, like, how are those vertical asymptotes and x-intercepts connected to how you answered problem A here. So go ahead and pause the video, answer those 3 questions, and turn back on, and we'll see how you did. All right, so let's take a look at our graph here. So now when we look at this, we want to know where is our function less than or equal to 0, which means where is it touching or below, all right, the x-axis, our horizontal axis here. Now, I say touching because notice we do get the equal to, so it's okay if it hits that bar. So if I look, I really have 3 sections of my graph, right? I have this left section, and it's to the left of our vertical asymptote here. I have this middle part of my graph, and then I have another vertical asymptote at 4, and then I have this part over here to the right. So I really want to just kind of go part by part and analyze it. So when I look, all right, okay, yes, all right, this whole part of the graph is below the x-axis. All right, so that interval would be negative infinity, 2, and I come to negative 5, right? So I get to negative 5 here on the graph here. But I never quite touch negative 5 because it is a vertical asymptote, so I do not include it. So I'm going to have an open interval. I'm going to have a parenthesis there. And we're going to union that. Now, when I come to the middle part of the graph, notice it's above here. It gets really close, and it looks like we cross right here, okay, right at negative 3. So that's where it's equal to 0, and then it's below, all right, 0 for the rest of that part of the graph. So then notice I get to include negative 3 here, all right, because it is less than or equal to 0. And then for the rest of this interval here, all the way to 4, notice where it gets really close to this vertical asymptote. But once again, it doesn't touch that vertical asymptote. And then when I look on the right-hand side here of x equals 4, right, we can see that we get this part of the graph, and it's going to be above, all right, our x-axis the entire time. So we don't get any more intervals where it would be less than or equal to 0. So now, let's go back and answer part B here. So now, vertical asymptotes we know are where the denominator is 0 and where we don't have a common factor with the numerator. So notice no common factors with the numerator here. So we get a vertical asymptote at x equals 4 and at x equals negative 5. We know we get x-intercepts where the numerator is equal to 0. So where x plus 3 is equal to 0, right? And that would be at negative 3, right? And so that we only get one x-intercept there of negative 3, 0. All right? And we can see how those play into the graph. So working on part C here, right? Moving to part C, how are the vertical asymptotes and x-intercepts related to those intervals, right? So when I look, right, here's our vertical asymptote at negative 5. Here's our vertical asymptote at 4. And then here's our x-intercept at negative 3. So notice those are kind of the beginning and ends, right, of our intervals here. And that should make sense to you because if we think about when we're looking at less than or equal to 0, greater than or equal to 0, we're going to look for where it's above the axis or below the axis. All right, and we know that at an x-intercept, that's where it crosses or maybe bounces, knowing some of the things we know from polynomials, right? It might hit the x-axis and bounce back up, or it crosses, right? And we know with vertical asymptotes, right, that gives us different sections of the graph. And we've seen this type of behavior right here, right, where we have one piece of the graph completely below or above here. So the vertical asymptotes and the x-intercepts really kind of break this graph into pieces where we can then check, right? We can then check, all right, each individual interval and see if it's above or below. So if I look, I really got one interval here to the left of that vertical asymptote. I really had a second interval here between that vertical asymptote and that x-intercept. And then I get a third interval here between that x-intercept and that vertical asymptote. And then I get a fourth interval way out here to the right of that vertical asymptote. So what you're seeing is that these x-intercepts and vertical asymptotes are breaking our graph into sections. And then we can just check each of those sections to find out, is that graph above or below the x-axis, depending on the inequality that is asking, or that we're being asked about. All right, so let's flip it over. Now do something very similar here on problem 2. So do 2A, 2B, and 2C. Once again, pause the video, flip it back on, and we'll see how you did. All right, so let's take a look here. So notice this time, right, we're looking for where it's greater than or equal to 0. All right, greater than or equal to 0. So once again, when I look out here, I have this part of the graph is definitely above the x-axis, right? And then it goes up that vertical asymptote right there. So my first interval would be negative infinity, and that looks like we have a vertical asymptote at negative 1. And once again, I don't get to include that, right? That's out of my domain, so it's going to be an open interval. Now when I look here, I get a piece of the graph that's below, then I hit right here, I go above, and then I hit again here. All right, and so I can see from 0 to 2, this piece of my graph is, all right, either touching or above the x-axis, so I get to include everything in this interval. And once again, notice I get to include 0 and 2 as part of my solution set because we have the bar here, greater than or equal to 0. So if I touch the x-axis, I can include it. And then notice once I cross 2, it goes back down and looks like it starts approaching another vertical asymptote here. All right. And then I jump over here to my final section. It looks like it's coming down that vertical asymptote. It's turning and getting really flat. And so this entire section is going to be above the x-axis. So, all right, and that vertical asymptote is at 5. And once again, we don't get to include it. All right, and then it's going to be above the x-axis all the way out here because we're going to approach a horizontal asymptote, all right, of 4, I believe, when we get all the way out there. Okay, so once again, now let's talk about how that connects, right? So our vertical asymptotes, we have 2 values in our denominator that make it 0. They are not common factors with the numerator. So we have x equals negative 1 and x equals 5 for our vertical asymptotes. Notice we have 2 factors in the numerator. So from this, we get an x-intercept of 0, 0. All right, from this factor, we get an x-intercept of 2, 0. Now, once again, how do these relate to the intervals, right? We can see that those values, right, are all included as the beginnings or ends, right, of each of those intervals. And once again, all right, we can see how that breaks our graph into intervals, right? So I have an interval, right, to the left of that vertical asymptote. I have an interval between this vertical asymptote and that x-intercept. It's a small interval, but it's still an interval. Then I have an interval between these 2 x-intercepts. Then I have an interval between this x-intercept and that vertical asymptote. And then I have this interval way out here, all right, to the right of that vertical asymptote. So really what's happening, and once again, just to emphasize this, and this is really the major piece of what we're going to do to solve rational inequalities, is we have to find those vertical asymptotes and x-intercepts. Because those are the only places where it could change, right? It could be above or below, all right? And once we know those, we can simply just test each interval to find out, is it positive, is it negative? All right, so that's really the big idea, and that's very, very similar to what we talked about with polynomial equations, right? Or polynomial inequalities, I should say. All right, so now let's flip the page and look at our process, right? Okay, so the first thing we want to do is we want to be sure one side of the inequality is equal to 0. All right, because that's really easy to tell, right, if it's above the x-axis or below the x-axis. So if it's not, right, then we have to make it so, and that's where we use some of those things that we've talked about with, all right, combining like terms, adding and subtracting rational expressions, okay? So then we use our knowledge of adding and subtracting rational expressions so that we have one side equal to 0. Now, once again, we have to factor the numerator and the denominator completely because that's how we know, right, where we have our vertical asymptotes and our x-intercepts, okay? We want to identify those x-intercepts, and we're going to label them on our number line. We're going to identify our vertical asymptotes, and we're going to label them on our number line. And we are really going to label them because that's going to tell us whether we can include or not include some of those values, all right? So we want to make sure we know when we put marks on our number line, are they an x-intercept or are they a vertical asymptote, okay? And then what we're going to do is select a value in each interval, and we're going to see if it makes our inequality true or false. All right, so if we want something that's greater than or equal to 0, when we plug in a value, we want to get a positive result, right? And then we're going to express our final solution in interval notation. All right, so let's take a look at a few problems here. So let's look at, all right, problem 3 here. So notice we want to know where x plus 1 over x minus 5 is less than or equal to 0. All right, so notice, all right, we're equal to 0, good, right? It's already all factored, right? We have one function over here, or one expression over here. All right, it's all factored. So really now we can just jump to looking for those x-intercepts and those vertical asymptotes. And so what I can see is I have x minus 5 here, so I can see that I'm going to have a vertical asymptote at x equals 5. From my numerator, I can see that I'm going to have an x-intercept of negative 1, 0. All right, so now what I'm going to do is label those on my number line. So I'm going to put negative 1 right here, and that's an x-intercept, right? So 0, 1, 2, 3, 4, 5 right here. All right, and that's a vertical asymptote. All right, and once again, that tells me, because notice it says less than or equal to 0, so I can include where it's equal to 0. So that means I could include negative 1, but I can never include 5 because it's a vertical asymptote. We know we've thrown that out of our working domain, right? Okay, so now when I look at this, notice now this divides my graph into 3 intervals. To the left of the x-intercept, between the x-intercept and the vertical asymptote, and then to the right of this vertical asymptote. So all I want to do now is pick a value out here to the left, and I'm going to plug it into my inequality and see if it's true or false, right? And we can pick any value out here we want. So I'm just going to pick negative 2, right? So let's see what happens at negative 2. So when I plug negative 2 in here, I get negative 2 plus 1 over negative 2 minus 5, and is that less than or equal to 0? So notice I get negative 1 over negative 7, and so I get 1 is less than or equal to 0. Well, that is, or 1/7 I should say, is less than or equal to 0. So that is a false statement, so we don't want anything out here. All right, now I need to pick a value out here, all right, between negative 1 and 5, and the easiest value in that interval would be 0. So let's see what happens when I plug in 0. All right, so I get 0 plus 1 over 0 minus 5 is less than or equal to 0. And notice I get negative 1/5 is less than or equal to 0. That is a true statement. This was false, this is true. So this interval, it looks good that we can take that interval right here. And then once again, now I need to test a value out here. All right, and I'm just going to take x equals 6. So I get 6 plus 1 over 6 minus 5 is less than or equal to 0. So notice I get 7 over 1 is less than or equal to 0, which is also false. So I don't want anything out here. So notice what this process is doing. When we have the graph, oops, wrong page. Let me roll this graph back over here. So when we have a graph, we have a visual confirmation of whether it's above or below the x-axis, right? So we don't need to test values. So what we are doing when we test the values here, all right, is we're confirming where that graph is. Is it above the x-axis? Is it below the x-axis? All right, and so what we know is that it's only above the x-axis or touching the x-axis on this interval right here between negative 1 and 5. All right, and now notice, since it's less than or equal to 0, I get to include my x-intercept here, and I'm going to go to 5, and I do not get to include 5 because it's a vertical asymptote. All right, and that's your answer. All right, so it's really all about finding those x-intercepts, vertical asymptotes, and then testing the intervals, all right, to find out where that inequality is true or false. All right, so let's look at number 4 then. All right, so notice as we go through this, okay, I'm equal to 0 on one side. I have one expression on the other side, so those first 2 steps are good. Now notice this time I do need to do some factoring. All right, so once again, I'm not going to go through the method of factoring, so if you need to pause the video to do your factoring, that's totally fine. But if I factor x squared plus 4x plus 3, all right, I need the factors of 3 that add to be 4, so that would be plus 3 and plus 1, and that's all over x minus 1, and that's greater than 0. Now, once again, we do need to look for holes, right, because we can't include those as x-intercept or vertical asymptotes. And notice this time we do not have any common factors, right? So we can just move ahead. So what I can see here is I'm going to have a vertical asymptote at x equals 1. All right. For my first factor in the numerator, right, I can see that I'm going to have an x-intercept of negative 3, 0. And then for my second factor in the numerator, I'm going to have a second x-intercept of negative 1, 0. All right, so now let's add these to our number line down here. So here's negative 3, and that's an x-intercept. Negative 2, negative 1, there's negative 1, that's an x-intercept. 0, and then there's 1 right here, and that's a vertical asymptote. Now, in this case, notice it's greater than 0. So we can't include any of our x-intercepts in this interval anyhow because we can't be equal to 0. All right, so we know everything's going to be an open interval for this particular problem. So notice now I have 1, 2, 3, 4 intervals to test to see where is this graph. Is it above that horizontal axis? Is it above the x-axis? So let's just take x equals negative 4. And I'm going to plug it in right here. So notice I get negative 4 plus 3 times negative 4 plus 1 over negative 4 minus 1, and is that greater than or equal to 0? So notice this is going to be negative 1 times negative 3, which is positive 3, over negative 5. So is that greater than or equal to 0? It is not, so that's false. So we don't want this interval out here. So that means it's below the x-axis. So now between negative 3 and negative 1, I'm just going to test x equals negative 2. So I get negative 2 plus 3, and then I get negative 2 plus 1, and that's all over negative 2 minus 1. All right, so notice now I get 1 times negative 1, all right, so that's negative 1, over negative 3, and that is going to give me 1/3 is greater than 0, so that is a true statement. So we definitely want that interval right there. Now I have to test between the x-intercept and the vertical asymptote here, so I'm going to take 0. All right, I get 0 plus 3 times 0 plus 1 over 0 minus 1 is greater than 0. So I get 3 in the numerator over negative 1. So negative 3 is not greater than 0, so that is false. So I don't want that interval. And then finally, I just have to pick something out to the right-hand side here to past x equals 1. So I'm going to go ahead and just take x equals 2. And then I'm going to plug that in. So I get 2 plus 3 times 2 plus 1 over 2 minus 1, and is that greater than or equal to 0? So I get 5 times 3, which is 15, over 1, and that, all right, is just 15 is greater than 0. That is a true statement, so I definitely want that interval out here. So I see I have two intervals that, all right, are greater than equal, or excuse me, greater than 0 this time. Now, since it's greater than 0, I know everything's going to be an open interval. So my first interval here would be negative 3 to negative 1, union 1 to infinity. All right, my friends, so that is our work for the day. All right, that's how you solve rational inequality. So be sure to do your video check-in, and we'll wrap up our unit with one final lesson next time.